Okay, so okay, guys. So good afternoon, everybody. So let's start. So I told you last time, guys, I started to teach assembly instruction last time. So I started with this section, data transfer instruction. I told you data transfer instruction. This section is like equal in C language. Okay. So for example, if you want to copy register to register, okay, immediate value to register, memory location to memory location, immediate value to memory location. That's what I'm explaining here. And I told you last time, we have load instruction. Here in load instruction, you are gonna copy memory location to a register, or you are gonna copy immediate value to a register. Okay, it's only, so this only used for that. Store is used only if you want to copy register to memory location only. If you want to copy memory location to memory location or immediate value to memory location, you have to use move instruction. I'm going to teach it today. If you want to copy register to register, that's what we transfer and also exchange instructions. Is that okay? That's all what. By the way, don't be confused. We use different English words like move, transfer, but all of them copy. You copy, okay? Anyway, so I explained. Load, store. I started to explain transfer. I told you in transfer, you can copy one register to another register. So here, after transfer, you have to put two operands here. You are gonna copy this operand from the left-hand side, you copy it to the right-hand side. And by the way, that's what we do for all instruction in this course. Okay, like move also from left hand to right hand. Okay, we always do that. So always we put the source first and then the destination second. Okay. Then I told you also, so you can do this for all registers. Also, we have something like shortcut. So we have TAB, which is similar to this one. We have TBA as one word, similar to this one, DSX. So this one is going to copy register S to X. And also we have TYS and so on. That's what I explained last time. Also, I started to explain something looks weird. Okay. So what I'm gonna start now is, if you transfer byte to byte, yeah, that makes sense. That's okay. If you transfer word to word, that makes sense. That's okay. However, you can also transfer a byte to a word or a word to a byte. So how can we do that? That's what I'm gonna explain now. Okay. So by the way, when you say transfer A, B, so you are gonna copy A and put it in B. So this instruction is not going to change A, but it's going to change B because B is the destination. The old value of B is gone, right? Anyway, so let's start with the first one. If you transfer a word to byte, how can we do that? I told you last time, guys, when you copy a byte, a word to a byte, you are going to copy only the least significant byte, only the first part here, not this part. Okay, we're going to copy this part to here. Now it makes sense. Now I'm gonna copy byte to byte. Yes. Okay. But tell me, how can we do, because this looks very weird. Why it looks weird? Because X should be storing a number. It's a word, but I cannot just take a part of the number. It doesn't make any sense, right? So the whole, everything in X should be one number, right? So it doesn't make sense to just take a part. What this part means, why you need to do something like that, okay? I give you one example we're going to do in this course. Then maybe, again, this is like a tool. Maybe we can use in different ways, but at least this is one example. You are going to need something like that, okay? Later in this course, we are going to need to do something like, if you have a number like this one, 372, for example, I want to display this number on the LCD. So I have to do some operations in order to get 2, in order to get 7, in order to get 3 out of this number. So this is just one number, okay? From this number, I have to extract the 3 digits. And then every digit, I'm gonna convert it to ASCII code and then send it to the LCD. That's exactly what we're gonna do, right? So if you have this number, I wanna get 2, then I'm gonna add 30 to make it to make it ASCII and then send it to the LCD, okay? Anyway, so I need to get the individual digit. If you didn't understand exactly what I said, that's okay. We're gonna teach later in this course. So the way, if you have this number, how can I get the individual digits out of this number? The way we're gonna do it by dividing by 10, right? So as I'm gonna teach later, we have an instruction to divide by 10. When I divide by 10, as you see here, the remainder is 37. Sorry, the quotient is 37, but the remainder is 2. So I'm gonna get this digit. If I divide this one by 10 again, I'm gonna get 7. If I divide it by 10 again, I'm gonna get 3 and so on. So by dividing by 10, you are gonna get them one by one. I need to get them one by one to convert them to ASCII and send to the anyway. So when I teach division instruction, the division instruction we have is going to store the remainder in a word. But in this case, I am sure the remainder should be less than 10, which is a byte. You get what I'm saying? So in this case, what you can do is, after you get a word, you are sure your number is here, and here zeros, just zeros here. You get what I'm saying? By this way, if I just want to take this part, okay, and then use it, I can use something like that. Okay. This is just one way to use it. So here I am sure, yes, I'm sure my number is here, and here just zeros because my number is smaller than 255. I'm sure. Okay, so I can get it this way. Anyway, any questions? Yes.
Is there a way to get the arithmetic out of
This is a programming language. You can do everything you want to do. But do you need this? Okay, do you need this? That's a question. Okay, but for sure you can. But you cannot do it using one instruction. You can use multiple instructions. So I'm going to teach, as I'm going to teach later, we have something we call rotate. So for example, if I rotate this byte 8 times, if I rotate 8 times, this byte can come to here and then I can take it. Or you can use another way, but it's not using one instruction. You have to write some code to do it. You got what I'm saying? Anyway. So now I want to explain the other case. What it means if you copy a byte to word, what it means, or how can you do this, and what it means. You got what I'm saying? That's what I'm going to explain now. So if you want to copy a byte to a word, actually, what's going to happen, that's what we call extension. So here we are going to do extension. What do you mean by extension? I mean, the same number I store in a word, I can store it in, the same number I store in a byte, I can store it in a word, right? Just put zeros on the left. You understand what I'm saying? For example, if you are storing in a byte 33, so yes, I can store it in a word. I can put 00, 33. That's what we call extension. So what we're going to do here, I'm going to extend the number from a byte to a word. Okay? What's important is the number in the word should be the same number in the byte. The same number. I don't want to change the number. I just want to store the same number, but just in a bigger space. You got what I'm saying? So by the way, so again, how this works, we're going to take this number, we're going to extend it to a word. But the way, it's not always putting zeros to the left. It's not always like that. Why? It depends. If your number is negative, you have to put ones, not zeros. Interesting. Because in case of negative numbers, ones at the left don't change the numbers. In case of positive number or unsigned numbers, if you don't want to change the number, put zeros. What you're saying. Okay, I'm gonna make it very simple. So look here, guys, as I said before, if you have something like that, FF in a byte, 1, 1, 1, 1, 1. I mentioned it before, it's -1. Is that okay? If I extend to a word, if I put zeros here, if this number becomes 255. This is not a correct extension. Extension means I have to get the same number again. The same number, okay? So in this case, if your number is negative and you want to extend it, and it is negative, you have to put ones here. Ones are not going to change the number. So if you have here if you extend to if, this is -1, this is -1. So I'm going to give you details for now anyway, okay? But what I want you to understand now, what I mean by the word extension. Extension means I have a number in a byte. I want to get the same number, but stored in a word, the same number, okay? So I'm going to go back here. Details are here. How can we do this kind of extension, okay? And why? But let me finish how first. So in case of extension, we have two types of extensions. Let me go back more. Yeah. So for extension, we have two types of extension. If your number is unsigned extension or signed extension, okay? If your number is unsigned and you want to extend it, just put zeros, regardless, okay? So for example, 11111 is 255. If I put zeros here in a word, I'm gonna also get 255. Very simple. So if the number is unsigned, okay, and you want to extend it, just put zeros, done, right? However, if your number is unsigned, in case of a positive number, also just put zeros, you will get the same number. I'm giving you example here. This number is number 3. So if I put zeros here to store it in a word, I'm gonna also get 3. Okay. So if your number is signed and positive, just put zeros. I promise you will get the same number. Okay. However, in case of negative number, you have to put ones, because in case of negative number, this is -1 and this one is also -1. To make it simple, in case of, make it simple, just in one statement. In case of unsigned numbers, if you want to extend unsigned number, just put zeros. Done. In case of signed, repeat the signed bit. If the signed bit is 0, repeat it. If the signed bit is 1, just repeat it. That's it. I promise you'll get the same number. Is that okay, guys? Okay. So the question is, do I need to do the extension by myself? No, usually using instructions. So some instruction are going to do signed extension, some instruction are going to do unsigned extension. I started with transfer. Transfer is going to do signed extension. Okay, we have another instruction, exchange is going to do unsigned extension. Right, guys? So what I'm saying, you are the programmer, you know in your program what numbers are signed, what numbers are unsigned. If your numbers unsigned and you want to extend them, so you have to use transfer. If your numbers are signed and you want to extend them, you have to use exchange. You have to use the correct instruction. Okay, anyway. Any question? You understand what I mean by extension? You understand how it works? Again, I'm going to repeat important thing. Extension means I want to store the same number. I don't want to change the number. It's the same number, but in a bigger space. Okay, guys? So why I mean need extension? By the way, we are going to do in a lab, not this week, but next week lab, we are going to do extension. Why? I'm going to tell you why. Okay, look here, guys. For example, if I have bytes, I want to add byte plus byte plus byte plus byte plus byte. Okay. For sure, if I keep adding byte plus byte plus byte plus byte, the chance to make overflow is too high, right? Because I'm going to store the result in a byte. So I'm going to add byte plus byte to store in a byte, byte plus byte to store in a byte, byte plus, you got what I'm saying? So if you keep doing this, yeah, the chance of making overflow is too high. So the way we are going to do it is, I'm going to take this byte, I'm going to extend it to a word, then add it, okay? Then this one extend it, add them, and so on. That's why you are. So in order to reduce the chance of making overflow. So every time I'm going to extend into the word, and then I'm going to add word plus word, word plus word, and so on. Okay. Anyway, this is one way to use it, but you should understand the concept itself, the concept of extension, what extension means, and why sometimes we need it. Okay. Okay. So transfer is gonna do signed extension for transfer. We have another instruction, exchange. Exchange instruction actually is gonna, it has to work on registers, no memory here, register. So this one is gonna do exchange. You know what I mean by exchange? Exchange mean the value, if I exchange, for sure this is how the instruction is. You have to write here EXG, and then you have to write here one of these register and comma one of these registers, okay? So what this instruction is gonna do, actually, is gonna copy A to B and B to A. You got what I'm saying? For example, let me give you example. If A is storing 20, B is storing 70, if I say exchange A comma B, so what? So after I execute this instruction, A is going to be 70, so 70 is going to come here, 20 is going to come. So it's simple. Exchange is going to do exchange values. However, if you say transfer, so instead of using this one, if I use transfer A comma B. So actually this one, I'm going to copy A to B. So after you execute this instruction, A was 20, is going to stay 20. B should equal to 20 as well. What about the 70? 70 is gone because you are going to overwrite it. Any questions? Great. Okay, guys. If you focus, you will be okay in exams and everything. I made it very clear. I said transfer is used if you want to copy register to register, not memory location to memory location. If you want to copy memory location to memory location, you have to use move instruction, as I'm going to teach it right now. I said exchange, you have to use it if you want to copy register to register. Okay. I remember in one year, I asked the students, this was in an exam. I asked the students, I want to exchange a memory location to another memory location. So some students did this one here. For sure, that's not true. That's not true. Okay. If you do something like that, because I made it very clear, this instruction exchange, there should be a register and register. Is that just is that okay? Okay. But do we have an instruction to exchange memory location to memory location? No, we don't. But that doesn't mean I cannot do it. Still, you can do it, but you have to write multiple instructions because I don't have one instruction to do that. Is that okay? So I'm gonna. So the way you have to use it, guys, as you see here in this picture, look here. Number one. I need to use a temporary location here somewhere. Okay. So number one, I'm gonna store this value somewhere here. And for example, register A, using load. This number one. Then I'm gonna move this one from here to here. Move, because move instruction is used from memory location to another memory location. Okay. And then after that, I'm gonna do store. So yes, I can do this one exchange, but I have to use 3 instructions as you see it instead of 1 instruction. So I'm gonna solve it later. You will see this example in details, but I just want to pay your attention to this point. When you use an instruction, you have to use it. You have to make sure you are using it in the correct way. When I say this exchange, it has to be register to register, so it has to be this way. I cannot put memory location to memory location. Okay, this is so I'm saying this, but for exchange, but this is applicable for all instruction I'm going to teach in this course. Yes.
So exchange has 2 memory locations.
No, exchange, there should be 2 registers after exchange, not memory location. Yes. It's going to swap the values. That's true. Is that okay? Same thing now, guys. Can I exchange byte to a word, and how it works? Exactly same thing as I explained to transfer. So when you exchange, actually you are going to copy byte to a word and word to byte. So exactly same thing as explained to before. When you copy word to byte, actually you are going to take only the most significant byte, as I explained before. And when you copy a byte to word, you are going to extend it. Is that okay? However, the difference is between transfer and exchange. The exchange is going to do unsigned extension. Transfer is going to do signed extensions. Okay. So when you transfer when you transfer byte to a word, So you are gonna do signed extension. This one is gonna do unsigned extension when you extend the byte to a word. Is that okay, guys? Any questions? Okay. Another important, interesting thing here, because you swap, it doesn't matter who is the source, who is the destination. There is, okay, it doesn't matter. That means if I say exchange A comma B, it's the same thing like exchange B comma A. Both of them are gonna do the same thing, right? However, for transfer, okay, it matters. So it's gonna be different. Who's the source, who's the destination? For example, if I say transfer A comma B, it's gonna be different from transfer B to comma A, right? Here you are gonna copy A to B. Here you are gonna copy B to A. It's gonna be different. Okay, guys? But here it doesn't matter because you are gonna, anyway, you are gonna copy this one to here, this one to here. Any questions? Any question? Okay, so now, very, very easy. I explained what I mean by signed extension, unsigned. I explained what I mean by extension. I explained we have two types of extension. If your number signed or unsigned, okay? I explained if you want to use transfer is going to do signed extension, and exchange is going to do unsigned extension. Okay. Here, I just want to explain another approach. Here, I want to explain another way to do unsigned extension. You know what is this? Very simple approach. Look here. If I wanna do unsigned extension to a memory location, for example, we don't have an instruction to do that. We don't, because even if you want to use transfer, okay, sorry, if you want to use exchange only work with registers, not memory location. Is that okay? So the simple way you can do it, guys, if I wanna read a memory location and I wanna extend it unsigned. So the simple way, I'm gonna read this one, put it in register B, and then I put 0 in register A. Now register D is the unsigned extension of this number. You got what I'm saying? Because in case of unsigned numbers, to extend, just put zeros on the left, right? So all what I'm gonna do, I'm gonna read this memory location, put it in B using load instruction. So here you can use load instruction, okay? And then you put 0 in A. If you do that, you can unsigned you can do unsigned extension to the byte this memory location, and now it is in register D. Any questions? Okay, great. Also, we have some shortcuts here for exchange. Again, as I told you, you can say exchange. You can put here register and then another register. This is totally fine. But we have also a shortcut. So also we have this one. So this one is actually exchange D to X. So this one or this one exactly same thing. You got what I'm saying? For this one also same thing. If you write XG DY, that's it. So this one is going to exchange D to Y. So exchange D and Y. This is going to be exactly same thing like this one. Again, the good thing now is, as I told you, if you go to I summarize all here. I have used tables here. So as you see here, guys, in the tables, I summarize all the instruction we have here. So you can use this transfer, or we have some shortcuts here. Same thing for exchange. You can say exchange and then use to register as I explained, or you can use shortcuts like these two. Is that okay? We have another one, we call it signed extension. We may not need it because this one is like is gonna exactly like transfer. Transfer is doing signed extension. This one also is doing signed extension. So here, this one signed extension, then you put here a byte and then you put a word here. And this one is gonna do signed extension. Okay. Any questions? That difficult? Very difficult or easy? Okay. So I want to tell you something very important because also it confuses students. Look here what I'm going to teach here. If you listen to me, everything will be okay with you, right? So look what I'm saying here. If I say transfer A comma X, as I explained, this instruction is gonna store in A in X after doing signed extension. Is that okay? So that's what this instruction is doing. However, If I say load B, A comma X, completely different thing. So here A comma X is completely different from A comma X. A comma X here is a memory location. It's one operand memory location. So what's gonna happen here? I'm gonna read the memory location, put it in B, pointed by X plus A. So that's what I want to say. A comma X here is completely different from A comma X here. A comma X here, two operands, and this one I'm gonna copy from this one to this one. This one is a memory location. So why is this confusion? No, there is no confusion. If you understand what I'm saying, there is no confusion. So how can I avoid this confusion? Very simple. You know, for transfer, what should come after transfer? They have to be two registered. No memory location after transfer. There is no confusion. Okay, so you have to understand the instruction itself. So after transfer, I should not put a memory location. I have to put two registers. So this should be a register and this one should be a register. After load, you have to put a memory location or immediate value. This one is not immediate value because you are not using hashtag. So this one, this means it's a memory location. Is that okay, guys? You understand this? Yeah. It's the same thing. So you mean if you signed extension A comma X, that's what you mean. If you use this instruction or this instruction is exactly the same thing. So what this one is gonna do is gonna copy A to X, but it has to extend it. In order to copy byte to word, it has to extend it. And this one is gonna do signed extension because exchange is gonna do unsigned extension. Is that okay? Okay. Very important because in the quiz, I just wanna I wanna just check. I wanna make sure you understand what I mean by signed extension, what I mean by unsigned extension. I want you to. I wanna make sure you understand that transfer is doing unsigned extension, exchange is doing signed extension. Okay. For example, if I do here, for example, exchange A comma X, and A was FF. Just as an example, because this one is doing unsigned extension, so what I'm going to store in X is actually 00FF, because this is unsigned. FF unsigned is 255, so X should be 255. Make sense? However, if this one, the same example, if I put here FF, because this one is signed, so X should be, FF here means -1. So X should be actually FF to keep it -1. This will be in the quiz. Okay, I just want to make sure you understand what I mean by signed and unsigned. It also be in the assignment. I want to make sure that transfer is gonna do signed, exchange is gonna do unsigned. Should I say it again? Did I say it quickly? Say it again. Okay, what I'm saying is that exchange is going to do unsigned extension. In case of unsigned extension, you just put zeros all the time. That's it. Is that okay? And because I don't want to change the number, I want to get the same number, but just in a bigger space. That's it. So if A is storing FF is because it is unsigned, should be 255. Okay, that means after I extend it to X, I should also be 255. That's why I'm going to put zeros here. I'm going to put 00FF. In other words, exchange always put zeros all the time. Okay, because the exchange is doing unsigned extension. So if this one is 255, I'm going to do 255, which is true. Okay. However, transfer is doing signed extension. In case of signed extension, I'm going to repeat the sign bit. If the number is positive, to get the same number, just put zeros on the left. But if the number is negative, to get the same number, put ones. Ones are not going to change the number in case of negative. If you put zeros, you're going to change the number. You're going to change the number. You're going to get a different number. And that's what I'm going to show you now. So for example, if A is storing FF means -1. Okay. So still, I want to get -1 in register X. So to do that, I'm going to repeat the sign bit, which is 1. So it's going to be FX here shall be FF, which is -1. If you put 0, 0, it's going to be 255. You understand it? So transfer is doing a signed extension. So when transfer is doing the extension, it's going to repeat the last bit, the signed bit. It's going to repeat it. Okay. However, exchange always put zeros to get the same number. Okay, guys, any questions? Okay, now I'm gonna move to move instruction. Okay, I'm gonna move to move instruction. So I told you move instruction is used if you wanna copy, immediate value or memory location to a memory location. Okay, you wanna copy immediate value or memory location to memory location. So after move instruction, there should be two operands after move instruction, one for the source, one for the destination. Okay, and the two operands should be memory location. Sorry, this one can be immediate value or memory location. This one should be memory location all the time. Is that okay? And again, as I explained before, when I say memory location, I mean it can be something like that. It can mean something like that, right? It can mean a comma x. It can mean 1 comma x plus. All of these are memory, as I explained before. Is that okay? So here, the destination, it has to be a memory location. One of these for sure. Okay. However, here it can be one of these, or it can be immediate value. Okay. So move instruction is used if you want to copy memory location to memory location or immediate value to a memory location. Is that okay? We have two types of move. We have move B for byte. We have move W for word. So this one is used if you want to copy byte. This one is used if you want to copy a word. Okay, guys? Any questions? Let's have examples. So let's have several examples here to better understand what I'm saying here. Okay, guys, let's see this example. Move byte. So move byte should tell me, number one, you are gonna copy a byte. That's number one. Number two, there should be two operands after it. So this is the sort, and then you put here hashtag, comma, and you put here 1000. Okay, very easy. So that means you are gonna copy immediate value, which is number 20. You are gonna store it in location 1000, and this is a byte. So after you execute this instruction, if you go to the location 1000, you should see number 20. Okay, guys. Again, as I told you before, you can put the number here. You can put it in hexadecimal. You can put it in decimal. You can put it in binary, whatever you like. Any questions? Okay, let's see something else. If I say move byte, okay, that means you want to copy a byte. Okay, and there should be two operands here. This operand is not immediate value because there is no hashtag. So this is memory location to memory location. So I want to copy a byte from 1000 to 2000. So, okay. So that means after you execute this instruction, you actually are going to copy the number here, or are going to copy it here. What about the old number here? Gun. Any questions? One more thing, very important, guys. Listen to me. We hate numbers. We don't like numbers. If your program is long and you have too many variables, we don't use numbers. That's why, as I explained before, for example, I can say org 1000, and then you make here definition for variables. You can say idc.b7 counter dc.b whatever. So you can define a number of variables here. Is that okay? And as I told you before, every time you use the name of the variable, which we like to use names, right? The code warrior is going to replace it by the number, by the exact address. Okay, so you don't need to worry about the address, just put the name. That is why, for example, here, guys, if I say here, move byte counter, comma 2000. So what code warrior is going to do is going to replace this one with the address, whatever the address is. You understand what I'm saying? I know when I tell a student this one, yeah, student like this one, they can understand it. But if I tell them counter comma 2000, they don't understand it. It's the same. They are the same. But here I'm going to use just the name of the variable, and code warrior is going to replace it by a number, by the address. If you want to do it, if you would like to use addresses, use it, but it's not convenient for us. You understand what I'm saying? Same thing if I say, for example, move byte I to k, and you already defined I, you defined k. So in org 1000, I dc.b whatever, k dc.b whatever. Okay, so this one actually so this one is going to replace by address, whatever the address is. For example, 2000, this one 3000. So you are going to copy from a memory location to another memory location. So again, please guys, when you see a name of a variable, don't be confused. This will be replaced by the number. So this is a memory location. Any questions? Okay, I have more examples here, or I have example here about because this also in the last lab. Yeah, that's exactly what I'm explaining now. But so when I say org 1000 counter dc.b I dc.b7, what this means? It means as we did in the last quiz, it means this. It means I'm gonna start from location 1000. I'm gonna store here 2, and then in 1001 I'm gonna store 7. Is that okay? So that means counter, every time you use the word counter, is going to be replaced by 1000, which is a physical location. Every time you use I, is going to be replaced by 1001. Is that okay? So what I'm saying, in your program, if you write something like that, move byte 1000 to 1001, it's going to be exactly the same if you do something like that. Why? Because code warrior is going to replace these two by the numbers, by their numbers. Okay. Any questions? Okay, one more thing, very important, very, very important. You should understand what is the difference between these two. Okay, guys, very important, because we are going to use it with arrays all the time. So let's see here, guys. When I say, again, there is no confusion here. When I say load x hashtag, this hashtag means immediate value. It's not memory, right? However, this counter here is going to be replaced by the exact location, which is 1000. Okay, this one also is going to be replaced by 1000. So what is the difference between, very important, what's the difference between these two instructions? Okay, again, I know when we use a word, some students get confused. Make it simple. This word is going to be replaced by a number, okay, the address. So here what's going to happen, here I'm going to copy the address of the counter, the address. So here I'm going to store 1000 here. Is that okay? Here I'm going to store a word at 1000, put it in X. So this one actually is going to store a word. So it's going to take these two, I'm going to put them in X, as you see here. Okay, guys? By the way, maybe for variables, we are not going to use this one a lot for variables, but for arrays, we are going to use it all the time. I'm going to tell you why. Hopefully it is here. No, it's not here. Because look here, guys. When I say, for example, org 1000, for example, and then I'm going to use buffer, any name, dc.b. This is the name of an array, 3721, for example, name of array. As I told you before, if I want to read array, number one, we're going to do it all the time. Number one, you have to initialize a pointer by the beginning address, this number one, right? And then I'm going to read increment x, read increment x. So number one, you have to initialize. So how we're going to do it all the time. How we are going to initialize, I'm going to say, for example, load x. I'm going to use the pointer x. I'm going to use load x, okay? And then hashtag buffer. Very important. So what's going to happen here, I'm going to initialize x with the beginning address of the array, because I told you, and this was a question in the quiz, last quiz, okay? I told you, when here I put the name of the array, So this one is going to actually be replaced by the beginning address of the array. Okay. Once you initialize X, so now you can start reading the array. Okay. I told you how. Usually, if the array is too long, usually you should have full loop. I'm going to explain loops later. And then I'm going to loop, for example, I'm going to say load accumulator A 0, X. Okay. And then you have to increment X. So every loop, every iteration, I have to read, then increment X. So I have to keep doing that. Is that okay? Or I told you I can do this two operations together. I can do both of them using one instruction. So I can say load accumulator A 1, X plus. So, okay, but just shortcut. But this one is similar to these two. Any questions? Good. So we're going to have we are going to do it all the time. Any questions? Okay, let's have more examples. I finished data transfer instruction, but just I wanna have more example to understand it better. So if I do something like that, guys, move forward. So you should know this instruction should copy a word. This is number one. Number two, what should come after this instruction, it has to be two operands. Okay. So here you are gonna copy. And then you can see very easy. This is immediate value. It's not a memory location because of the hashtag. So so what this instruction is doing, you are gonna copy this immediate value to this memory location. Because this is a word, this one is gonna take two locations as you see here. So this one is gonna take two locations, 1000 and 1001. We are gonna store the most significant first. Okay, guys. Number two. Okay, move to the next. To understand, examples are very important to understand this one. Here in my handwriting, I have several examples. In the chapter itself, also there are a lot of examples there as well. Okay, any questions? Let's see another one. Move forward, not byte, move forward from 1000 to 2000. What it means? It means I want to copy a word from this memory location to this memory location. And because it is a word, I'm going to take 1000, 1001, 2000, 2001. That's okay. That's exactly what I did. So what I did here, I'm going to copy a word at 1000. I'm going to put it at 2000, as you see here. You understand? Okay. Another one, move byte. Again, after move, there should be two operands, right? So this is a memory location, and this is another memory location. So here I'm gonna copy a byte from this location to this location. So as you see here in this figure, I'm gonna take a byte here from location 1000. I'm gonna store it in the location pointed by X. Okay. Let's see next one. Move byte. So here means I'm gonna copy a byte, and what should come after move? This one here, it has to be a memory location or immediate value. This one here, it has to be memory location. So now, yes, this is two together and these are two together. Okay. So now I'm gonna copy a byte from this location to this location. So as you see here in the figure, I'm gonna copy from the location pointed by X a byte to the location pointed by Y plus 1. Okay. Again, it's not difficult. I told you for memory, you have this format. You should understand what this means. For memory, you have 0, X or 1, X or Y. We have also this format. We have A, X or B, Y or whatever. We have also this format. We have 1, X plus or 2, Y plus. So once you see any of these formats, this is a memory. You need to know, you should learn how these formats are different. And I already explained them before. That's what we call addressing moves. Okay, any questions? Okay, let's see another one. So here, guys, I want to do something like that. I'm going to say move byte A, X, B, Y. Okay, very simple. So again, what should come after move? It has to be two operands. So this is one operand, this is memory, this is one operand memory, and you are gonna copy a byte. So as you see here, guys, I'm gonna copy a byte from location pointed by x plus a to a location pointed by y plus b. Is that okay? Let's see more examples. When I say move byte 3a to 1000. Yes, what this means? It means I want to copy a byte, which is this immediate value 3a, to the location 1000. So after you execute this instruction, if you go to the location 1000, you should see 3a. Okay, let's have more example. When I say I'm going to execute the same instruction here, but instead of saying move byte, I'm going to say move word. So what's going to happen? Instead of storing this one in a byte in one location, I'm going to store it in two locations. Okay. And simply because you don't put anything here, all the time, I'm going to put zeros. If you don't put anything, so this one has nothing to do with extension. Don't be confused with extension. Here, if you don't put anything, CodeWord automatically is going to put zeros here. Okay. This is different from instructions. So that's exactly what happened. So if I execute the same instruction, but instead of B, I'm going to put W, this is how it's going to look like. So actually, CodeWord is going to put here 2 zeros. So I'm going to store it in two locations this way. This is for byte. If you use byte, this is for a word. Easy, right? Hopefully. Any questions? Okay. Okay. Now I want to show this example here. I told you if I want to exchange a memory location, this was in a test before. I want to exchange a memory location to another memory location, byte. So I want to, this is a byte and byte, this memory location, this memory location. Okay. I told you I cannot use exchanging instruction because exchanging instruction works on words, not bytes. Okay. So I have to do it using 3 instructions, as I told you. Okay. Number 1, I have to store this value somewhere. For example, in register A, this is number 1. Number 2, I have to move from here to here. Number 3, I have to do store this way. Okay. So I'm going to solve this example in 2 different ways. One way, if I want to exchange byte, if this is a byte and byte. Also, I'm gonna explain if they are words, if 1000 and 2000 are words. I'm gonna explain. We want to exchange instruction at 1000. Exchange a byte at 1000 and byte at 2000. I want to exchange them. Also, I'm going to explain if I want to exchange a word at 1000 and a word at 2000. Okay. So let's start with the first one. As I told you guys, number 1, this value here, a byte, I have to store it in A. Store it somewhere. Okay. And to do that, for sure, load instruction. Load instruction is used if you want to copy immediate value or memory location to one of the registers. That's what I did here. So here I'm gonna load A with 1000. So this value at 1000, I'm gonna store it in A, right? Number 2, I want to copy a byte from 2000 to 1000. If you want to copy memory location to memory location, move instruction. That's what I did here. So I'm gonna say here, move byte 2000 to 1000. Always this is the source, always this is the destination. Finally, I want to store a register, the value I put it here to 2000. So I'm going to use the store this way. Are you okay? Any questions? Very simple. Very simple. You have to see what you want to copy. If I want to copy memory to memory, it has to be moved. If you want to copy register to register, it has to be transferred. If you want to copy register to memory, it has to be stored. If you want to copy memory to register, it has to be stored. Load. Now I want to repeat the same example. But for words. I want to exchange words. How it would be different? Very simple. It's going to be the same thing. But for sure, I need here a word. So instead of A, for example, I'm going to use something that's a word like X, for example. Okay. So now I'm going to read the word from location 1000. I'm going to store it in X. That's exactly what I did here. So I'm going to read the word. How can you know this is a word? That's what I said multiple times. I can know from the instruction itself. This instruction for words. So I'm going to read the word from 1000, put it in X. This is number 1. Okay. Number two. Now I want to copy a word from 2000 to 1000. Copy a word. So that's exactly what I did. I'm going to say move word 2000 to 1000. So this instruction is going to copy a word from here to here. Is that okay? Finally, I have to store X in 2000. When you store X, as I said before, you are going to copy a word because this is X. Any questions? Any questions? Okay. Let's have more examples. Let's have more examples. This instruction is very interesting. I love it because this instruction actually 3 instructions in 1 instruction. Very compact. I'm going to tell you how. So in this instruction, guys, it's move byte. So I'm going to copy a byte from here to a byte from here. Okay. From memory location to memory location. Okay, guys. So to make it simple, what this instruction is going to do is going to move byte in location pointed by X to a location pointed by Y. Also, it's going to increment X, increment Y. You got it? So as I explained before, 1 comma X plus, so this one is going to be 0 comma X, and then increment X by 1, because 1 here. Is that okay? So actually, as you will see, this instruction is useful. So here in this example, I'm using 2 pointers, X and Y. When we can use 2 pointers? Actually, as I told you before, we use pointers if you have array. What if you have 2 arrays? 2 arrays. I want to copy 1 array to another array. In this case, we will do it. I think this will be also a question in the assignment. I'm going to post the assignment today or tomorrow. So for example, guys, if you have 2 arrays, okay, I want to copy this array to this array. Okay, so for example, I'm going to put X here, I'm going to put Y here. Then in every iteration, I'm going to copy 1 byte to 1 byte. This is 1 iteration. Next iteration, I have to increment X, I have to increment Y, and then copy this one to this one. Very simple. Again, assume this is 1 array and this is 1 array. So I need 2 pointers. I'm going to use my 2 hands. Okay, so this is a pointer here, this is a pointer, X and Y. I'm going to copy from here, and then increment X, increment Y. Copy, increment X, and increment Y. Copy, and so on. Is that okay? So to do that, guys, in order to copy, I can write something like move byte 0 comma X, 0 comma Y. That means I'm going to copy a byte from X to Y, and then I'm going to use increment X, increment Y. Okay, so this is okay. Also, in a short, if you want to make it short, you can just write this one. So this one is going to do exactly the same thing like this one. I know this is a little bit confusing to students, but try to pay some attention to it. So this one here, guys, means 0 comma X. Regardless of what number you are using here, even if you use here 20, whatever the number is, this one means 0 comma X. This number means how much you want to increment X. Is that okay? And by the way, all the time, by the way, if it is array of bytes, listen to me, if it is array of, now this is example for array of bytes. What if it is array of words? Array of words, how it would be different? Number 1, instead of using byte, I'm going to use word. So that means every time I'm going to copy a word. Are you done? No, I'm not done. What else? 2. That's true. Because every time I have to increment by 2. And this instruction is very interesting because, you know, if this instruction, how many instructions are here? It's 5 instructions. How? So this one can be actually move 0 comma X, move word 0 comma X, 0 comma Y. Right? This number 1. Then increment X twice, then increment Y twice. Is that okay? Any questions? Yeah, this is just what I have just explained before. If you want to do signed extension to 1 memory location, I told you I can put it in B. Okay, using load instructions, you put it in B, and then you can clear A. So I'm going to explain this instruction later. This one is called clear A. Or you can clear A by putting 0 in A. So this one or this one. Again, what I'm explaining here, guys, if I want to do unsigned extension to a byte in memory, I told you the way you can do it. I can read this byte, put it in B, and then I have to put 0 in A. How can I do this one using instructions? Okay, very easy. If you want to read a memory location, put it in B, load instruction. Okay. How can you put 0 here? How can you put 0 here? Also, I can use load to put 0. I can say load A 0. So I'm going to put number 0. Is that okay? Or I'm going to teach later this instruction. It's called clear instruction. So this one is going to clear. Any questions? Yeah. This is the example I have just explained right now, guys. I told you if you have two arrays, for example, you have array 1 and you have array 2, as you see here. Okay, guys? I want to copy one array to the other array. Number 1, you have to initialize the pointer. And I said, how can you initialize the pointer? You can see here, guys, here. Right? Always we are going to do this. You have to initialize X. You have to initialize Y by the beginning address of the array. How can we do that? You have to put hashtag and then you put the name of the array. Because this name is going to be replaced by the beginning address. Okay. So here I'm going to store the beginning address in X, the beginning address in Y. And then as you see here, guys, in every iteration, in every here, I'm gonna for sure explain later how can make loops. But in every iteration, we have to copy a byte from location pointed by X to a location pointed by Y, increment X, increment Y. Okay. Or instead of using 3 instructions, you can just use 1 instruction. That's exactly what I have explained. Okay. If it is array of words, I would use this one. Okay. How many times you have to loop? How many times I have to loop? It means how big is your array. If your array has 100 elements, so I have to loop 100 times. Any questions? Okay. So I am done with data transfer instruction. Okay. So tomorrow, the lab tomorrow, it has 2 parts. The first part is very easy. It's about data transfer instruction. As I told you, in last lab, I know some students didn't finish the second part. So you can work on the second part tomorrow. Okay. Also, you can work at least on the first part about data transfer instruction. Okay. The second part of tomorrow's lab is about addition and subtraction. Okay. So I'm going to teach addition and subtraction now. Okay. For quiz tomorrow, you are going to have 2 quizzes tomorrow. Okay. One quiz about addressing modes. Okay. Addressing modes, I just want to make sure you understand. You understand what I mean by, for example, if I say load A1000. Okay, so I said this one last time. Okay, so I'm going to give you like a memory, and there is 1000 here. For example, 3A. After this instruction, I'm going to tell you what is the value of A after execute. I just want to make sure you understand. So I'm going to use, in the first quiz, I'm going to use only load and store instructions because I want to test you in the address mode. I just want to make sure you understand if there is hashtag, you understand it or not. If there is 0, X, you understand it or not. Okay, so this is the first quiz. Okay, the second quiz is going to be about data transfer instruction. In the second one, I want to make sure you understand store, what store is doing, move, what move is doing, what exchange is doing. Is that okay? I'm totally fine if you want to tomorrow, you have only 1 quiz about data transfer, about addressing modes, and we move the data transfer to next week. I'm totally fine. Okay, if you want to do that. But anyway, tomorrow's lab, you have to do a lab tomorrow about data transfer instructions. So whatever you want, I'm totally fine with that. Okay, but so again, data transfer instruction: the store, load, transfer, exchange, and move. This instruction I taught today and last time. Okay. Any questions? Okay. Now, yes. You mean what I understood from you? Number one, if I want to read array, I have to initialize X. Is that okay? Then you have to use it in a loop. So if the array is 100 elements, so I have to loop 100 times in every iteration. I'm going to work on one element. So in iteration 0, I'm here. In iteration 1, iteration 2, iteration 3, okay, and so on. After I finish, your concern or your point here about after I finish. Is that okay? So after I finish, your point is that and you want to use X again for another array, so you have to reinitialize it.
No, for the same array.
No, if I finish, okay, so I'm done. So I don't care about where is X. You understand what I'm saying? Do you care about where is X? Maybe your question or what you're confusing is, look here, because in the very beginning, X is the first element, okay, and then after I finish, I increment X. So when I finish the first iteration, X on the next one. So what about the last one? So after I read the last one, so X is going to be pointing at next one, okay, but I'm not going to use it because I'm done. You can say you can modify the code so that X can be one before, but you don't need to overcomplicate it. So X can be one before, and then in every iteration you increment first and read, increment first and read, increment first and read. But there's no way to no need to overcomplicate it. Okay. So what I'm saying is, if you read and then increment, yes, after you finish the array, X is gonna point on the next one. Next one is a location in the memory. You got what I'm saying? But I'm not gonna use it. I'm not gonna keep reading it. Okay. But it's still a location in the memory. So there is no a physical boundary. It's gonna tell me no, don't put X here. It's gonna be a location in the memory. What is stored there? I don't know. It may be a variable. It may be an instruction. Whatever is stored there, I don't care because I'm not gonna read it if the program is correct. Yes.
What do I do if I need to reverse the array multiple times?
You want to reverse the array multiple times?
Yes.
So what do you mean?
For example, you are sorting an array of
Yeah.
numbers. Sometimes go through a bubble sort. It's not completely sorted. Go through process one.
Yeah.
So you have to do the process.
Yeah, it depends on how you are gonna program it. If you need multiple arrays, you can do that. It depends on how you will do it. If you want to do it in the same array, okay, but you have to be careful because if you overwrite a location, what was there is gone. You got what I'm saying? Yes, you can have multiple arrays. So for example, I have array. So for example, to do the sorting you're talking about, I need to have another empty array and then do the sorting. It depends on how we want to do it. Okay. So now I am done with data transfer instruction. Simply, as I told you, data transfer instruction is similar to equal. How I can make a register equal to register equal to a number, memory location equal to memory location, and so on. And then, so I'm done with this section. If you wanna, I already explained many examples here. If you wanna practice more, so if you go to here in the slides, I give you also several examples. You can see also several examples here in the slides here. Okay, so you can see many examples here. Okay. So now I'm gonna move to the next section. The next section is about data transfer instruction. So in data transfer instruction, okay, we have number one, addition and subtraction. So we have an instruction to do addition, subtraction. We have an instruction to do increment and decrement. We have an instruction to do complement, and complement here we mean the ones complement. So we have an instruction to do the ones complement operation. We have an instruction to do negate, and negate is the two's complement. So you know what I'm gonna explain, but you know what negate means. Negate means you multiply, you negate a number, so you multiply by -1. So, and as I said before, if you multiply a number by -1, so actually you calculate the two's complement. So we have an instruction. If you have several instructions, I'm gonna teach. This instruction is gonna calculate the two's complement. Okay, so you will see. Also, we have some instruction to set or clear some flags. Sometimes, as you will see in the examples, Sometimes I need to clear some flags. Sometimes I want to set some flags. Finally, we have an instruction for multiplication and division. So let's start with addition and subtraction. They are very easy. So for addition, guys, we have only, by the way, you can see, you can notice in assembly, we don't have too many instructions. We have a limited instruction. That's why the programs are long. You will notice that, right? Because every instruction is related to the hardware. If we have too many instructions, the hardware may be too complicated. You got what I'm saying? Anyway, so that's why we don't have too many instructions. Number one, in case of addition, we have 3 instructions to add 2 registers together, to add 2 registers. For example, we have ABA. This instruction does not need any operands. This one is inherent. So I explained before what I mean by inherent. That means you don't need to put here any operand next to it, okay? So what this instruction is gonna do, ABA, this instruction is gonna add register A to register B and then store the result in register A. Is that okay? We have another one here, ABX. So this one is gonna add register B to register X, store the result in register X. Is that okay? We have ABY. So this one actually Y should equal Y plus B. Okay, guys? That's all what we have for adding register to register. Okay. You can add A to B, store the result in A. You can add B to X, right? And you can add B to Y. Okay, in this case, why sometimes you need to add something to X or Y? Because you are using as pointers. It's pointers. You got what I'm saying? Sometimes I want to add a number to X. I want to add a number to Y. You got what I'm saying? To get an address because they are pointer. For example, X is pointing here. If I add 0 to X, I'm gonna get element 0. If I add 1 to X, I'm gonna get the address of element 1. If I add 70 to X, then I'm gonna get the address of the location numbers or element number 70 and so on. So now, the second set of instructions we have here. Here you can add, I can add a register to memory location or immediate value. So here a register should equal a register plus memory location or immediate value, as you will see right now. Okay. So for this one, we have only 3 instructions. We have add A, add B, add G. That's all what we have here. So let's see the first. So all this instruction, you have to put here one operand here, only one operand. This operand can be immediate value or it can be memory location. When I say memory location again, it can be any format I explained before for memory location. So what this instruction is doing, actually, register A should equal register A plus a byte, because these 2 instructions are gonna add byte to byte. So these 2 instructions are gonna add bytes. This one add register D, so this one for word. So what's gonna happen here? I'm gonna add a memory location or immediate value plus A, store the result in A. This for bytes. Same thing here for B, right? Last one here, register D should equal register D plus memory location, a word from the memory location or immediate value. So this is okay. That's all what we have here. Very, very simple. That's all what we have. Okay, guys. So you can notice here why we call register A, B, G. We call them accumulator. We call them accumulator because most of the instruction here, the result is going to be stored in A or B. Okay. One more instruction. We still have 2 more instructions, and that's what we have for addition. What this instruction is do, look how it works. Add register A plus memory location or immediate value plus the carry flag. So this instruction is exactly similar to this instruction, add A, but the difference is that in addition to adding A to memory location or immediate value plus 1 bit, which is the 0 flag, the carry flag. What it means? It means if the carry flag is 0, I'm going to add 0. If the carry flag is 1, I'm going to add 1. You got what I'm saying? This is how it works. Why? This is something else. Why you want to add the carry flag? This is something else. For sure, there is a reason. I'm going to explain why. But you have to understand. this instruction, you are going to add a byte A to a memory location or immediate value. That's it. We have another version. We have another version from this instruction. We call it add with carry. Add with carry. As you see here. In this case, add with carry. So we're going to add register A plus memory location plus carry. For sure, I'm going to explain why you want to add the carry. You understand, if I want to add byte to byte, yes, that's okay. If I add word to word, that's okay. But why you want to add byte plus carry? I'm going to, for sure, I'm going to justify it. Same thing here. We have another one here, add with carry for register B. Okay, this one B plus B should equal B plus memory location immediate value plus carry. That's all what we have. Okay. So let me summarize them again, guys. So for addition, we have only 3 instructions to add 2 registers, A plus B, and then the result is going to be in A, B plus X, and then the result in X, B plus Y, and the result is going to be in Y. Or if you want to add a register to memory location or immediate value, we have only 3. Add A, and then here you put one operand here. This operand can be immediate value or memory location. Same thing for add B. So this one is going to add A plus immediate value or memory location, store the result in A. This one is going to add B plus memory location or immediate value, store the result in B. So this is byte. So add byte to byte. We have another one that add D, register D. Okay. So this one is going to be register D, which is a word. You are going to add it a memory or immediate value. So this memory is a word. So here you can see I can add byte to byte or word to word. The last 2 instructions we have similar, add A but with carry. So A plus memory location immediate value plus carry. Add with carry for B. We don't, so we have here similar to these 2, but add with carry. We don't have add register D with carry. We don't have this one. Okay. So this all the instructions we have. Okay, guys. Before I give you example, I want to jump to subtraction. Yes.
Does that first A, B, A, always A, B?
Yeah, always.
Always.
So always, this one is going to add A to B. Yes. Okay, before I give you example, I want to jump to subtraction because subtraction will be very similar to what I explained right now, but it's going to be instead of addition, it's going to be subtraction before I give you examples. So if you go see subtraction, maybe it's right here. Again, guys, I think this is very useful to look at the tables here. So if you see here, guys, I put summary here in these tables. Okay, so everything I explained is already here in the table. So this is for addition. If you look to subtraction, we have exactly almost the same instruction for subtraction. For example, we have here add A to B. We have another one, as you see here. By the way, these brackets here doesn't mean memory location. Okay, this bracket, it means register A or register B. It doesn't. Okay, this means when you say OBR, so this is a memory location. Anyway, so let's see the first one. Here you add A to B. Here you subtraction. So what this instruction is going to do, SPA. What this instruction, you are going to subtract register B from register A, store the result in A. That okay? We have also here, you can subtract in it. This is exactly similar to add here. So add A. Add A to immediate value or memory location. So here we have subtraction. Here, look here, guys. You say subtract. Here you subtract a memory location or immediate value from A. So this one is exactly similar to this one, but this is addition. Here, this one is subtraction. You subtract memory location a byte from memory or immediate value. You subtract it from A, store the result in A. Okay. Also, here this one is exactly similar to this one. Okay. Here you subtract SUBB. Okay, and then you have to put here one operand. This operand has to be immediate value or memory location. This one is used if you want to subtract immediate value or a byte from memory. A byte memory, you want to subtract it from B and to store the result in B. Okay. The last one here, similar to add register D here, similar to this one. Okay. So you can see here, but this is for a word. This one is for a word. So you can here actually, you can subtract immediate value, or you can subtract immediate value or a word, a memory word from register D to the result in D. So the conclusion, guys. So all the instruction we have here, we have similar instruction here, okay, except these two. So here you add, here this one. We don't have similar one here in subtraction, these two. Everything else is the same. Is that okay? Including the one with carry. I told you about this one. Here, I'm gonna add register A to memory location plus carry. Or I wanna add A to immediate value plus carry. I'm gonna tell you why you do carry. I'm gonna explain it. We have a similar one here, subtract, but I'm not gonna say carry. I'm gonna say borrow, B-O-R-R-O-W. So in case of subtraction, we call it borrow. Just borrow, B-O-R-O-W. I'm gonna explain for sure why. It's a carry. It's the same. It's a carry. But in case of subtraction, it's gonna be borrow. I'm gonna explain why later. But if you see here, guys, this one is exactly similar to this one here. So here you add A to immediate value or memory location plus carry. Here you subtract immediate value or memory location from A, okay, and you subtract the carry as well. Okay. Anyway, I'm gonna continue next time. Okay, guys.